All right, let's pull up. It sounds vaguely familiar. The issue is we don't know the z-score, so I gotta remember the z-score.
I'm trying to look up in the reading right now. You can find it.
Hi, Nico. Oh. We can stay here.
So the equation I got for z-score is x, the mean, minus the known u, which we don't know that, divided by O, which we do know. That's what we get the z-score.
Yeah.
It's like, well, we can't get, because we need the z-score, from my understanding, to get the margin of error. So nobody had this figured out. This one was difficult. So
I'm gonna look it up right now. So yeah, we need the z-score because then you divide the sample size. The sample size would be the square root of the sample size over under the standard deviation, right? Yeah.
Yeah.
Yeah. So then it would be mean plus or minus the z-score times standard deviation over the sample size. That's how you would get the margin of error.
Yeah, but we need the hang on. What was the first question it asked us here? Determine the margin of error, and then you got to go. Okay.
Yeah. Now you can have to get the z-score.
Okay. Oh, hang on. Let's go back another lesson.
This is in lesson 11, isn't it, guys?
I thought it was in 10.
Then look at the wrong place.
It should be in the recap.
Yeah, it's there as well.
The value. So the value times the mean. That would be 0.
Why is it so hard? God.
Well, it's just it doesn't give us all. I assume we're missing something. And this, what is it?
This. So we're going to use the applet. I know that to find the 0.95.
So what is so? Okay, so let's go back here. Where is the? So I mean, determine margin of error for this 95% confidence interval. So this one, it's all about margin of error. Now, isn't that a very simple
Equation?
Yeah, hold on a second. I got too many screens open. Because isn't
standard deviation minus the confidence interval, like the so the 0.05, so it ended up being 1.95.
But well, let's see.
Does that make sense? What I'm saying?
Say it again.
Yeah, I was.
Hey, so
So do you remember the
Yeah,
margin of error is always the opposite of the confidence interval? So we're 95% confident, so it would be 0.05, and you'd minus that from the standard
that's
deviation.
starting to sound familiar.
You remember that? So I'm thinking it's like 1.95,
Wait, what is 1.95?
the margin of error.
But isn't just the margin of error? Isn't that just m equals? So I'm looking in chapter 10. It says we use the letter m to denote the margin of error, and it has the equation m equals 2 times the standard deviation over the sample size.
Wait, but didn't the 95% actually equal a specific number? I always forget.
Yeah,
It
actually,
does.
yeah, it does. It's point. It's the actual number. Okay.
hey guys, so
Walker, I think you're onto something.
I went back to lesson 10. Remember all those formulas I used to do by hand? So I just start plugging in my numbers. I have 1.96. I have no idea if that's correct. But
Hold on, wait. I'm doing the math real quick. Hold on.
Look, if you're
So
in chapter 10, look under that subsection 4, putting it all together.
don't we, to find the z-score, don't we just put in the confidence interval and the applet? Do you remember that in the area? And we put 0.95, and then it gives us a z-score. And I
yeah.
got z-score 0.063.
Doesn't sound right.
But do we need a z-score to get the margin of error?
Yeah, so now we have the z-score, so we can get the margin of error.
So wait, what did you get? What was your margin? What did you get again?
For the for my margin of error?
Yeah.
Or the z-score.
Okay, what did you get for your z-score?
So I put it in the applet because you remember that's how we got the z-scores a lot. Anyways, and I got 0.063.
0.063 times what is O? Standard deviation is 2 over 4.
Hey guys, we're complicating this.
Yeah.
It's actually, they gave it to us. 90% is 1.645, 95% is 1.96, and 99% is 2.58. So it is 1.96.
Yeah, that's what it was.
We don't have to calculate anything. It was given to us.
How was it given to? Can you explain that to me again? Why it was given to us?
In lesson 10, so when we're trying to find the confidence interval, we would enter that number as a critical value, the area outside the confidence level. So if we're looking for 90% confidence interval,
a 95. Okay.
Let me show you. I can show you my screen.
Yeah, can you do that?
I'm just going off like what my stuff that I had in chapter 10. Hold on.
Sorry, I don't want to make this like super more complicated, but do you guys remember specifically the calculation for the margin of error?
Yeah.
So repeat
the z-score times
z-score.
Can you guys see
by n?
Can you guys see my screen?
Yeah.
So here's what I have. So here's our confidence intervals. 90% would be 1.645, and that was off of chapter 10. I'm just looking at my old notes, my old stuff I did. And so whenever I would go into here to play around with these numbers, if I wanted a different confidence interval, I would just enter it. For example, if I wanted 90%, I would enter that number. If I wanted that to change my confidence interval to 99%, I would enter 2.58.
Okay, yeah, but that's...
How did you get that? That's fine.
No, that's given to us. I'm starting to remember that.
Determine.
I'm going back to lesson 10 so I can see it because
that might be the z-score. That's not gonna. I don't know if that would be our margin of error. So it might be 1.96 times 2 divided by 4.
Divided by square root of 4, isn't it?
What was that?
Isn't it the square root of 4?
Is it the square root? Did I say that wrong?
Wait. Here, it should be 29.64 then. So What's our standard deviation on this answer? Hold on this
2.
question.
2
2?
or point, whatever it is,
So 2, so it's 0.01 then. Hold on.
2 millimeters.
No, because never mind. We're looking for the margin of error. That this doesn't.
No, wait, no. So it is 1.96 because
Yeah.
you do 1.96 times 2 divided by the square root of 4, and you get 1.96.
Yeah, it's 1.96. I just did it too.
It's 1.96.
Yeah, I got that. So if the median then is 1.96, then it's minus 1.96. All right,
we
and that is a viable answer for the calculations, because in the chapter review, it gives us A, B, C, D. So and that so it would be okay. Well,
In that review, it was. Let's see.
it was chapter 6. Yeah, so it was A was 998.040.
Right. And that's what I got was A in that.
Wait,
Okay.
But
what
this is the margin of error we're after.
The margin error would be the 1.96. So,
and then wait, did you guys already say number? You guys already got number 7? Isn't it just 998.040?
yeah.
Okay.
Yeah.
And the next one would be just 1001 point. What is
196. 1001.
001.960?
Yeah.
Or am I okay?
It's 1.96. Yeah.
All right.
That's
one I need to.
Yeah. Sorry, never mind.
Okay. Well, that's a good one to remember. That'll save us a lot of time.
Yeah.
And that was found in lesson 10. Well, thanks, guys, for getting us there.
Yeah, that was complicated.
Did you guys, who's on chapter 10? Just in there right now.
I am.
Where are you at in 10? Just out of curiosity, like under what subset or whatever? What little section?
I'm just looking. I was just bouncing around, so I was just trying to read.
So what I was going through earlier today was in that, if you can scroll down to little section 4.
Yeah.
All the way down to section 4. Where it says putting it all together.
Yeah.
You go down 2 or 3, 1, 2, 3, like 4 sentences where it says we use the letter M to denote the margin of error. And at least for this problem, I was kind of following this today, or trying to. And that still makes the 1.96 viable?
I believe so, yes.
Because, I was using that as it's staying close, so I don't know. But I was using that as a guide today. That M equals.
I get what you're saying there, too. Because
Up a little bit. Just trying to see.
But I still think I know, because I know it talks about those problems.
I was just using that as an example.
Scrolling down, if you go a little more precision, right? If you go down to 4.1, it says a little more precision. It talks about how the actual formula, because it's showing that M equals 2 divided by the what is that? 0 divided by the square root of n. If you go down a little further, just that next section, a little more precision, it actually says that I remember it now vaguely, that actual equation is 1.96. The z-score is specifically that number.
One is used as an approximation for the actual value. Okay.
Yeah, there you go. All right,
Gotcha.
so that's why, which is good because that's the I'm positive that's the right answer. Just got to make sure I know the rest of them.
Yeah. Let's see.
Okay. All right, moving on though, right?
Yeah.
Yep.
All right. Where are
So
we
we're at
now?
9 now, right?
Yeah. To access the accuracy of a laboratory scale, a standard weight that is not. Okay, I was looking at this one earlier as well. Okay. Okay. That's in the review. This equation is given to us in the review.
I got 38. Is this the right one?
So I got 38,416.
Yeah, so did I.
What's the standard deviation for this?
0.01.
0.01.
Okay.
Yeah.
And then the what is the margin of error? Do you know what the margin of error is on this one?
Yeah. Greater, less
Zero,
than.
zero, one.
Yeah.
What is it?
0001.
Yeah.
0.0001.
That's the margin of error?
Yeah.
Yeah.
Oh. Okay. Oh, that's what it was.
Wait, how did you guys get what you got? You got like 3,000 something?
38,000 sample size.
How did you get?
416. So that equation is
What did you get? What was your answer?
38,416 is the sample size you need.
Oh, that's what I did wrong. Okay. Yeah, I got the same answer. I just want to make sure you're gonna do it.
Okay,
Man.
just really quick. Are we playing this in an Excel? Because I'm a little bit lost right now.
I did it on a calculator,
I did on calculator too.
I did.
but
on
I should probably have done it on Excel.
I did
Okay,
on that Excel sheet.
there's a separate equation. It's found in the review
Okay.
that you'd use that for to get that number. Let me pull up the section again. Computer's moving slow.
It's like
So
section
Z
5.
score.
Yeah.
KG, I can show you. I can show you my screen and the
Lesson 10 recap.
Yeah, that's where it's at. So
Sample size formula.
Yep. All I did is just put that in. I did it on Excel though, but it gave me the same answer, so
yeah, no, I'm probably gonna start using Excel again.
it's a little quicker, I feel like.
I agree.
Did you get it, KG?
Yeah, I'm going back to it right now so I can look for that equation right now.
Here, let me just show you. I think I'm sharing my screen. Here's what I did on Excel. Here's how I got it.
Sweet.
Here's my equation. Can you see it?
Here, let me just try to make the screen bigger here. Okay. Click on that again. Okay.
There it is.
So G10 times H10. Awesome. Okay, perfect.
All right. Okay. Oh, this is helping out a lot. Okay. 10. The mean area U of several thousand apartments. I got D for this one,
Oh,
but I could be wrong, but I think it's D.
I think you're right.
Yeah, same here. I think you're right.
Okay. Yeah, I feel pretty confident. You know, the attendants think that it's smaller, so that's their alternative hypothesis. Okay.
Yeah, exactly.
All right. I think I got D for the next several answers. So I wasn't 100% on all of them, though. Okay. A statistical test of hypothesis.
You got D on 11?
I think it's B.
Yeah, I'll just.
That's weird. I wonder.
I think either
I
A or
must have read
B.
wrong, 'cause that is right. That is right. Is that different on this test? Probably not. Huh. I'm off tonight, guys. Sorry. Because that's obviously the right answer.
Yeah.
Okay. A group of statistics students wants to determine if it's getting a better grade. They collect. This is C. I got C for 12.
I'm still reading it.
Okay.
I'm rereading
That's
it.
one I
for the-
skipped.
I'm
when I
rereading
was-
it for the 5th time.
I wasn't sure. So how did you get that one exactly? What did?
Okay, because we know that it's an ANOVA, and so we
Yeah.
need for the requirements to be met to do the test, there has to be two things: that the sample sizes are normally distributed, and since they're 15, so they're short of the central limit theory or central theory limit.
Yeah.
You need to do the Q plots, and so it talks about that. They collected 15 from each different apartments. The data from each apartments are bell shaped, meaning that like
No liars, yeah.
so.
You're right.
No, right? So they're normally distributed. So Q plots are the histograms, and then
Yeah.
and then it says the second thing, the sample variations are all equal. Remember that, like the largest can't be 4 times, it can't be equal to or larger than 4 times the largest variance
Yeah.
of the group. So that was from the last lesson.
Yep.
A medical researcher is working on a new test type of cancer. The average survival time.
It's type 1.
Concept-
I get those confused.
X,
Type
the null
1.
hypothesis.
So I think it's type 1 when you reject it and it's right, isn't it?
I'll pull that up. That's easy enough to find out. I get those really mixed up.
Yeah, me too.
Sounds.
I believe you're right.
This class was a breeze for the first couple weeks, guys, and now stuff is just getting so confusing.
It is
Yeah.
confusing.
Like all these terms and stuff, I can't keep it all straight.
Where's that at?
That should be like 9, or I think it's 9. When we reject a null hypothesis. Yeah, you're right. It's one.
One. Okay.
This one. If you determine the ending. Because that's when you reject the null hypothesis, but the null hypothesis is true. Type 2 is when you don't reject the null hypothesis and it's not true.
That's false. Yeah, it's not true.
They just say it weird. They're like, you failed to reject the null hypothesis and you should have, or they say something weird like that. So
I know, and it's supposed to be plain English, but that does not sound like plain English.
Yeah, that's all
I'm sure
twisted.
there's some statistical like English reason why, like some random situation where the plain simple English was technically wrong.
Yeah.
So all right.
A on 14. Just makes sense to me. If one goes down, the other must go up, right?
Yeah. I remember that from the reading. Oh, suck. You guys there? Oh, dang it. You guys there?
Yeah, on 15.
Yeah, hang on. Sorry, my computer just glitched. What is going on? Hang on real quick. I need to go get something from my computer. I'll be right back.
Okay. Hey guys, isn't this one where if it's smaller than
Yeah.
it's smaller?
Yeah, if it's smaller than 0.05.
Yeah, that's right. Yeah.
Yeah.
So wouldn't this be failed to reject then, or no?
You reject it.
You would reject it. You wouldn't fail.
Oh, okay.
So it'd be D.
Oh, okay.
Would it be independent? 16.
You'll have to look at them.
Oh, yeah, we're gonna-
I can't remember where how these tests were.
I think it's actually paired sample t-test, but that's just a guess.
What's the one sample? But
Well,
it's
one
one
You just have
sample.
one variable.
Yeah, but they're being combined. They're not separating. So wouldn't it be one sample?
Oh, does it say combined?
Well, it doesn't say combined, but it doesn't say they're separate by male students and female students. So they're all together in one bunch. They're not comparing the two, right?
Well, it says test if those means are different.
What question are you guys on?
16. I think it might be paired, but that's just what I'm thinking. I don't know.
Okay. It's independent samples t-test.
Oh, it is. That was my first guess.
And
Why
the
would you say it's
reason
independent?
is that the male students that you choose doesn't determine the female students
Oh,
that.
yeah, that's right.
Say,
Right.
say that again, Zach.
So the male students that are chosen does not determine the female students that are chosen.
You are right.
Forgot about that rule.
Yeah, it's a little tricky one. So I've gotten that wrong more than once too. So
That next one
Did you say D or B?
thing is it based on what we're talking about?
okay, education.
Wouldn't it be B as in boy with
This yes, that's what I got.
because they're depending on each other?
Oh, hang on. No, it's D.
Yeah, because that's what I thought. Because if you select a brother, you have to select a sister in the same house or
Yeah.
whatever.
What's
So the brothers score. I mean, like their their academic achievement isn't going to necessarily compare to the sisters. Like it doesn't. It's not determined by the sisters. The dependent sampling is because you chose the brother, so you have to choose the sister according to the
In the
study.
same home. Yeah. Yeah.
Keep forgetting about the independent. Yeah, so it'd be D. Okay. So I got A on 18.
Okay.
Oh, sorry, you guys have been that in.
Yeah.
I agree.
Okay.
Yeah.
Next one, margin of error.
Oh no, there we go.
4.967.
What did you get?
Maybe I'm wrong. Are you on?
I got
the-
2.025.
Oh,
What did you put?
I know why.
Why?
Ignore mine. Because I forgot to change some things on the.
Okay,
On
yeah.
it.
So which one are you guys on?
19?
No.
Yeah.
Like what? Where are you getting these calculations from?
I once again went back to my thing that I did.
Okay. So the confidence level, standard means. Hang on, let's clear this out. And what did you get for the? Oh, and then I didn't get the mean. Okay. Shoot.
Are you on the one sample
What are your
test?
confidence intervals?
Say that again? The
What are your
confidence.
confidence intervals?
You mean the upper and the lower bound?
Cheers.
Yeah.
Let me see what I got on those.
Where are you putting this stuff in, Zach? What are you putting it in?
I'm putting in the quantitative interference. What do they call it? And then I'm
Procedures?
doing it in the one sample t test.
So
Yeah, that's what I'm at too.
on
Okay.
my
My only question is what's the hypothesis and what's the type of test? Do we not have that?
So the confidence level, the hypothesis should be 0, I think.
Yeah. Okay.
Okay,
And
and
then
then
the-
times. What was the standard deviation?
What I got on here is 4.326.
Okay.
Yeah.
So the margin of error, what'd you guys get for 19 then? Because I'm confused.
So I'm gonna redo it on the other sheets, but what I got from just doing it on my little thing was 2.025, but I don't know that that's right.
And then how many? And then it's 20. Fuck. Okay.
Wait.
Hang on. I can read. You gotta be quiet. Oh, I did not get that. That's not right. Oh, that's probably why.
Do you remember how we got this, Zach, by minusing it from the confidence intervals? Do you remember that?
I do remember that. But
You know
I don't know
what I'm
if my
talking
confidence intervals are right, to be honest with you. All right.
What'd you get for your confidence intervals? I got 11.168 and then 15.217.
That's what I got.
Yeah, so I'm pretty sure that's right. I just forgot how we. Do you remember that? How we
Wait.
subtracted it? I'm trying to think about that.
What did you get? What did you get? 11 what?
0.168 for the lower and then upper 15.217.
Yeah, that's the same thing I got.
I'm pretty sure that's
What
right. I'm trying to figure out how we got the margin of error before. Because I remember there was a way.
Okay, so I know how, because what we do is we get the means of those two together.
Yes, that's what it was. Thank you.
So to this. Number 2.
So to the
So 13.193, and then you subtract that.
And then you take
divided
Yeah.
two.
this minus this equals.
So the formula that I have is the confidence
So
level.
2.025. Is that what you got?
Yeah, that's what
That's
I
what I
have.
got.
That's the
Hey,
answer.
now just where did you get those numbers from again?
So what I did is I have the confidence level, that 95%. I plugged in 1.96, and I divided that by the square root of the sample size.
You just divided the square root. You just divided 1.96 divided by the square root of the sample size.
Yeah,
And that's what it got you? Is
Yeah.
that how we're supposed to do it? Because we haven't been doing it like that, I don't think.
Yeah, I know. I was like, dude, that's I didn't know that worked.
Yeah.
So-
I think it's because I've been doing it. Like, remember a couple weeks ago, that's when I started getting all falling behind because I was doing it myself. But there's a point that I can't keep doing the numbers of myself, and so that's kind of where I'm lost. I'm kind of between using my old stuff that I created and then all the stuff they gave us. So
when I do 1.96 divided by the square root of the sample size, I don't get the correct number. Let me go back and look because
What did you think?
1.96
hold on.
times standard deviation, right?
Yeah,
Divided by the square root
of
of
the
the
sample size.
What do you have for
Sample
the What do you have for the sample size?
20.
20.
Yeah.
Yeah, shouldn't it be? What's your standard deviation again? 4.326.
4.326, yeah.
So it should be 1.96 times 4.326 divided by the square root of 20, right?
That's what I thought. Oh, and then you have to square that number though.
Again?
Yeah, then I believe that's the equation.
Well, that's
What
a
is-
sample size.
No, wait, that's not right.
That's a sample size equation that you square everything by.
So I'm getting I'm getting a little confused by all the different equations. I need to
I'm
write
so-
them down. Is what I need to do.
I'm confused too.
I think it's.
Oh,
yeah, I
okay,
think
hang on.
we're on the right track now.
I'm getting a few different things mixed up. Don't listen to me.
Well, I think
Okay,
you're on
so-
the right track though with the M. your margin of error is equal to your 1.96 times the standard deviation over the square root of your sample size.
Okay, say that again. So because it's just 1.96. That's why I did it wrong. So it's 1.96 times the standard deviation divided by the square root, right?
So did you get 1.90?
Yeah, that's what I got. 1.9. I'm assuming 1.900 is what we're
Yeah,
going
1.90. Yeah.
Times.
No, I don't know.
Oh, actually, well, like if it's got to be like 3 decimals, wouldn't it be just like 1.896?
Oh yeah, it would be. If we're just doing 3, yeah, it's pretty long.
Even then, though.
How did you do it for Zach or Graham? Where'd you guys get it from?
So we just took the average of the upper and lower confidence interval, and then subtracted it from the upper confidence interval, and then that's what you get.
More than I should.
And that's how we've been doing it in the past.
And that's gotten us the right answer every time, right?
Yeah, it's gone us every time.
But I want to make sure that we're doing it right, though. 1.96 times.
Because I thought
I
we just
agree.
had a discussion about margin of error.
Hold
Did we
on.
talk
Let me try to look it up on the book.
That was like the one in chapter 10, I thought, or lesson 10. Where I was thinking it was 2, but we're doing it more precise, and it's 1.96 if you're doing 95.
I agree with what you're saying. And I'm confused by the numbers I'm getting myself, to be honest with you.
So, Graham, what is it if you did it your way, like finding
Well, it's technically Zach's way, so not taking credit for it. But so all we're doing is taking the average of the confidence intervals and then subtracting them from the upper one. That's all we're doing.
So what does that give you for this instance?
It gives you 2.025.
That's what I have, according to what I put in the. So I'm trying to look just for the flat out. What is it? Hang on. What is this? It should tell me. The margin of error.
Well, I'll stick with the 1.896 and we'll find out.
Wait, hold on.
Because if you got the 1.896, your confidence intervals should be different than ours.
Yeah, it should be different.
Doesn't make sense either.
I don't know.
You guys got 2.025. 2.025, right?
Yeah.
That would make more sense with our confidence intervals.
I agree. That's why I'm stuck. Like there's something I'm not getting.
Because with the 1.896, I'm not getting the same confidence intervals.
Yeah, crazy.
Hey, Zach, Graham, and KJ, I think you guys are right. I'm
just every time. We're not following that equation at all, and that doesn't make sense.
So what I'm doing is I'm just changing it on my notes to do what you guys did.
That's cool.
That makes more sense.
That's not how we're supposed to get it at all.
It's the right answer every time, though. So that's why I don't get it.
Let's just do it that way because I agree. I mean, like it's equaling out to our confidence intervals.
Well, that's what matters, right? Getting it right.
Yeah.
Yeah, that's what I think.
And if we get it wrong, we can always come back and fix it. So are you going with 2.025?
Yeah.
Yeah.
Minus 20 would be 11.168.
Yep.
Hang on. Is that right? Yeah, that's right.
Okay, and then on 22, I got C.
I'm still plugging everything in.
Okay.
Oh, please. This hasn't happened.
Hopefully I'm doing it right. What one are you plugging it in on?
Oh, me? No, my computer's moving really slow. I'm trying to save my answers because my computer's acting weird. So
Oh, okay.
it's just moving really slow.
The good thing I can do, actually, I'm going to save mine too.
Just trying to make sure everything's. I don't want to have to redo everything. Okay, 22.
Okay, what number are you guys on now?
22.
22. A random sample. There is a difference. Okay. So I got C
Yeah, that was the one I got too. So
for 22.
Okay.
what I got too. So
All right, now we're all caught up.
and on this for the upper and lower, my number's huge. So I don't know if I'm doing it right on the right one.
Okay, just make sure you're putting it in. All right. It's type of sell a price.
So I did it in the 2 sample t-tests. Is that correct?
What did you get for the lower and upper?
What the is opening?
I'm just saying which one we put it in. Would it be a 2 sample t-test or would it be a pair?
I think it's a pair.
No, it's not. It's not paired because paired is dependent, right?
Yeah,
It's,
and this is in.
Yes.
it's not. It's not paired.
Yeah,
It's-
no pairs
So
are
I put
good.
mine in a 2 sample t-test, and I got for lower I got negative 423.238.
Okay.
You can tell me if it's right.
Did you get 5-4 something for the next 5-4? What was that? No. Never mind.
So plugging everything in. All right. Where are we at now? Los Angeles. Oh, that's my problem. Okay.
So what did you guys get?
Dude, I'm a few minutes behind.
Did you get 5417, Graham?
For upper?
Yeah.
Yeah. 5417.336.
Yeah.
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 Okay.
You got 423 for the lower, right?
Get it at negative 423.238.
Yeah.
Yep. Okay.
Okay, well, what did you get? Okay, hang on. I gotta test all this. Not equal to
That doesn't matter. You only have to worry about the 0.95.
Okay, what did you guys get again?
For the lower, we got negative 423.238.
Okay,
And then upper 5417.336.
all right, that's what I got.
Okay. All right, now this one is split up into 3. The next one. Gonna be on the Nova.
Did you also get C for 25?
I'm still. Let me check what you're looking at. Yeah, it's C. Sorry, I was already putting in the things into the ANOVA before I even looked at that question.
All right. That's why.
Okay, for the score, I got 7.978.
Yeah, that score.
Yep. The test statistic. P-value 0.002.
Yeah. Okay.
What number are you guys on, guys? No one's really talking.
I'm on 28 with you.
Oh, okay. No one agreed with me, so I didn't know what was going on.
I'm behind. I'm falling behind. That's why I have an answer because I don't have those answers yet.
Oh, okay. So you're just using the ANOVA.
Which of the following is best expressed? These level of significance. There is sufficient evidence.
We should just get the answers by plugging it in, right?
Yeah,
Yeah. You
Okay.
just get the answer.
I got D for 28.
You got D or E? I didn't hear what you said.
D as in dog.
Okay. I was
What'd you
sorry.
get?
I was reading through them, so I'm reading C right now. So 1 second.
Okay.
Did you guys get? I'm
I
sorry,
agree with
guys. I'm sorry, guys. I'm just a little behind. But for 26, did you get 7.978
Yeah.
and then 0.002?
Yep.
Okay.
All right. Now the direct flight one. Let's see.
And I'm just gonna go with what you guys said on 28, so I can catch up, guys. Is that cool?
Yeah.
So we got A, B, C, D.
I'm not sure exactly. 29.
Okay.
Do sample t-test.
Okay, the purchase supply and demand act directly on the price of all airline tickets as the seats available.
It'd be dependent sample. So it'd be a dependent, right? I mean independent, sorry. Not dependent. It'd be A. What I think.
Yeah, I agree.
Okay.
Because when they take it at 90 days, they have to take those same flights at 14 days.
Yeah, exactly.
So
We've done this before.
a pressure supply. Can you guys explain? Because wouldn't it be dependent? Can you explain why you think it's independent instead of dependent?
No, it is dependent.
Oh, okay. I thought you guys were saying independent. So you guys got
That's what I thought. That's all.
E. Okay.
No, it's dependent because when they choose the flight 90 days to see if it changes at all, the price changes, they check it at 14 days. So they're dependent on each other.
Okay, cool. I thought you guys were saying independent, and I just didn't understand why that was. The test statistic.
Test statistic 1.685.
I'm gonna be behind you guys at this point.
All right. Oh wait, no, never mind. 1 second.
Oh no.
What confidence interval? I mean, confidence level will be, but that's what I'm trying to figure out.
Sorry, man. I'm waiting on my computer. It's still having a hard time. Again, it's loading really slow.
Fine.
Today, so.
I was trying to save my stuff, but it says I have an error somewhere, so I'm trying to figure out what it is. It says that
Hopefully, it doesn't kick you out.
yeah. Oh, I know what it is.
So 1.685 is what I got for the test statistic. I don't know if that's correct, but
Okay, hang on. Okay, what did you get? 1.685. That's what I got.
okay. Now my question is it going to be greater than, less than, or not equal to? Let me read it again.
It should be equal to 0.
Yeah. Okay. So that means the value
Not equal.
is
Not equal.
yeah. So it's 0.96.
0.096.
That's what I
Yeah.
have.
0.06.
What? Hey, you got what test did we drop this into? Because it's dependent.
Paired.
Okay, I got it in there.
So you want to
Yep.
make sure the confidence level is 95. The
Yep.
null hypothesis is 0.
Yep.
The type of test is not equal.
Not equal to, yeah.
Oh, hey, what is the number of samples that you used?
Who are you talking to?
Walker, how many samples did you use?
Let's see.
What is your N for both variables?
88.
For both? Okay. I don't know what's
Yeah.
going on. Are you getting our same answers?
So your T number What was it again?
1.685.
Mine's 1.670.
What in the world?
What?
Are you sure you have it at not equal to?
Yeah,
And that wouldn't change it. The T-score.
not equal. 95.950 not equal to.
What's your mean for both variables?
Variable 1 is 268,858,
Okay.
Mm-hmm.
and 2 is 244,064.
That's it, because it's 234.19 for variable 2 for me.
I got 0.64. 0.064.
But what did you get? You got 1.865, right?
For your T-score?
Yes. 1.8. Is that what you got, Zach?
I got 1.685.
Mine's 1.670.
Hang on. What the heck's going on
I
here?
don't know.
I'm gonna put mine in again. I'm gonna.
Guys, I'm so tired on it. I'm so tired on it.
Oh, man, this doesn't look. Hang on. Is everybody getting the same N as well? 88?
Mm-hmm.
Yeah.
Yep.
Oh,
Yeah.
gosh, dang it. One.
Why is that this?
Zach and Graham, you guys both got the same answer, right?
Yeah.
No. Yeah, me and Graham did. Somehow, although our calculations and means are different, our p-value is the same. At 0.0.
Well, let me see. What was your low value? Sorry, I didn't even say that.
Wait, what
My
was
low
that?
value. What did you say? Your confidence interval? Is that what you were asking?
No, I was wondering what your p-value is 0.096, right? Well, that's what it would be for the test.
Yeah, and then the statistic is 1.685.
Yeah, that's what I have too. I wonder why.
Yeah.
How about you guys, with the sake of time, do you want to just try that and then we'll move on and figure it out?
I'm just gonna.
I'm thinking because I gotta get going soon. So
Yeah, let's just do that and let's move on to the next one.
Okay, which the best expresses the conclusion? Oh, hey, that's wrong. We're supposed to use a 90%. So our answers would have been wrong. You use a level of significance. And how did I put this in here?
so it's still the same. It won't change anything though.
Yeah. I'm gonna change it real quick.
Okay, I just want to make sure also that I input my data correctly.
Yeah. I know what you're saying, but it won't change
Like that.
No, I mean, because we're supposed to. Okay, I inputted my data incorrectly.
Because it does matter if you put it in the first or second spot, right?
The order.
Well, it depends on how you have the difference set up, I believe.
We're supposed to. Are you saying we put it in the wrong row?
I might have
Possibly.
find them wrong. I don't know. Because I remembered that did matter.
Is that what it says in the first? Let me go back.
Yeah, because it wants you to subtract the 90 from the
14.
Oh, okay. So yeah, we did do it wrong. Dang it.
Oh, dang it. I did that wrong too. So 90. Hang on. Hang on. All these dumb things are getting in my head. No, I think I had it right.
So my
I
P-score
did
now
mine
is
right.
and the statistic is negative now if I do that.
No, I believe I did mine right initially.
I think so too. That's why I'm confused.
Yeah, sorry, I did mine right. I just got the which ones were which mixed up. Okay.
So your 14 days was your variable 1?
Yeah. This equation is weird.
Yeah. So what did you guys get for 32?
I put B.
Okay, there is insufficient. I agree. There's a difference in the mean. Okay, there is insufficient evidence to conclude that there is a difference in the mean cost.
Yeah, I agree. It's B2.
There's insufficient evidence to conclude that there's a difference in the mean cost. What's the? Hang on, what is the difference? Oh, there. Oh, you think it's B? It should be.
Yeah, I'm pretty dang sure it's B.
Yeah, you're right. Sorry, I was thinking of the 95% interval.
Okay. All right. Submit it.
Let's
All
try
right.
this.
Looks like we're good.
Yep.
What do you mean?
Well, I just submitted it. We got 100.
Oh,
Yeah.
sweet.
Yeah, I just got it too. So I gotta go though, guys.
Sweet.
Yeah, me too. I'm gonna go take a test right now, so I don't forget.
Yeah. Anyways, you guys have a good night. Later.
See you
Okay,
guys.
we'll
Nah.
see you.
Bye. Thanks, guys. See you later.
Bye.
We'll see you,
Bye.
man.
Bye.